Hello everyone. In this video, I'm going to talk to you about how to deploy a contract, a Solidity contract using Web3PY. Keep watching. So in our Solidity do-it-yourself tutorials on the same channel, we have developed this contract, which is fifth payable contract. And this contract is written in Solidity, and we are going to deploy this contract using Web3PY. This is how we do it. So the first of all, go look at my videos on Solidity. The GitHub link is in the description section below. If you want more details on this contract, there is a series of videos that develop this contract on, and you'll get enough information there. So from the Solidity do-it-yourself, fifth payable contracts, I'm going to go and compile it. So I'm going to say compile, and I'm going to select 8.8, 8.8. I'm going to say compile. Once you compile the contract, the Solidity contract, you go to compilation details, and compilation details would have a Web3 deploy and ABI. ABI is an application binary interface, which gives you all the functions and all the inputs, all the variables that are available as part of this contract. So what you're going to do is copy this ABI and paste it somewhere else. Next, what you need to look at is the Web3 deploy piece. In this, you have the data. Just copy the entire data line or just this piece of the data. Just copy it. It's a big one. That's why I double-clicked on this one and it'll copy it. Now, what is this data? This data is the hex of the entire contract. So hex of the entire contract, which is going to be deployed on the blockchain, right? So we're going to copy data, and we are going to copy this button. It is going to copy ABI, which is like a JSON. You're going to look at it in a few minutes. Now, what you're going to do is head over to the collab, and if you remember, we had in the previous video we had include constants, which had our Infura URL and the private key from account, and add a variable known as contract data and copy the data in the hex format that we got from the Solidity compilation details. Next is the contract ABI. Contract ABI is a JSON which gives you all the functions, as I said, and the variables which is available in the contract. You need both of them. And at the end, you're going to return Infura URL, private key of the from account, the account which is going to be deploying the contract data, as well as the contract ABI. Please note that the order of these variables are important in order to capture it in the code that we're going to write to deploy the contract. All right, so what we did was we got data and ABI, we set it in a file, include constants, which already had Infura and private key from account. Next is I'm going to, and you can save this file under here, you see include constants. Please note that once you shut down the browser, this file is going to go get deleted because this is one-off. So you may save this on a Google Drive, and then you can do that piece as well. So for now, you have this include constants, and then I'm going to write the code now. So I'm going to say import include constants as incl. This is a handler, this is the alias, and this is the file include constants. Next, we know that it's returning 4 key parameters: Infura URL, private key from account, contract data, and contract ABI. And this include dot get constants. Get constants is the name of the function that is going to be called here. And just to make sure that these variables are correctly read, I am going to say print Infura URL, contract data, as well as contract ABI. And for obvious reasons, I don't want to print private key from account in the video, but you can do that as part of your development cycle. Now I'm going to execute this, and you would see that this is run. And Infura URI, contract data, and the contract ABI is inputted. Next, I'm going to make a little bit more space for this. Now, let's deploy this contract on Goerli net, the Goerli etherscan.io. So the first step, and obviously you have to install, this is a notebook which we have been using. You have to install the Web3, pip install Web3. We've already done get balance from account and send an ether transaction. Now we are going to be doing deploy a contract. So here from Web3, import Web3, the regular one, import JSON because we have this as a JSON, and this JSON would be then used to deploy the contract. Now, the contract ABI, whatever JSON you got, you need to use JSON.loads, JSON.dumps contract ABI. Now, what this would do is the contract ABI, if you do a type of, it is being read as a dictionary or list. So JSON.dumps is going to change it to string, and then JSON.loads is going to convert it back to JSON. So this is what is happening, right? So if you do a type over here, and if you run it, what you are seeing is a list. So contract ABI is a list. This piece converts this list to a string. So JSON.dumps is going to convert this into a string. And then JSON.loads is going to convert the string to a JSON. That is what we are doing. Make sense? If not, just Google it and understand what these functions would do. Next, I'm going to create an instance of Web3 as it is an object-oriented programming. This is an instance. So Web3.http provider passing the Infura URL. Next, we're going to define the from account. So this will be the account which is going to deploy the contract. I'm just putting two account. We are not doing anything with this two account in this code, but it is just there as part of the code. Next, nuns. We have been discussing nuns in the previous set of videos. So web3.eth.get transaction count from account. So because we are using from account to deploy the contract, we're going to find out the latest nuns, and then we are going to print it. Next, create a transaction object. Now, remember three things. This is we are going to be doing. Create the transaction object, sign the transaction, and send the transaction. We are not sending here ether at all. We are going to still follow the same steps. Create, sign, and send. So create a transaction object, nuns, from account, to hex, gas price, and data is equal to contract data. So nuns, from account, there is no to account. Gas price, you need to put a big number here because this is going to actually create the contract for you. The gas price data is contract data. So this is the transaction object. Please remember that in the previous video, while sending an ether transaction also, we created the same thing, transaction object, sign and send. So we will follow the same principle. So we got the transaction object created. Next, we are going to sign the transaction. So signed object equals to web3.eth.account.sign transaction. Exactly similar to the previous one. We are using transaction object and private key from account. It may not be a bad idea to pause the video and look at how all of these things are working. Next, send the transaction. So send transaction web3.eth.send raw transaction. We're going to use the signed transaction object dot raw transaction, and then print the transaction hash. So we're going to take this transaction hash, go to the Goerli transaction hash or goerli.etherscan.io, and you would see that the contract is deployed. And then we can read the contract address once the contract is deployed using this wait. Now, this statement was not there in the previous video. This statement, what it does is it waits for the transaction receipt. So web3.eth.wait for transaction receipt is the function with the send transaction. So again, we created the transaction object, passes to the signed transaction object. From signed transaction object, we use the raw transaction and we send the transaction. This is going to be a transaction hash. And then we are going to wait for the receipt of the transaction hash. And then we're going to print it. Transaction receipt dot contract address would be our the contract which is deployed. So with that said, a quick recap. We had these 4 variables in the include. We read these 4 variables. We got the contract data and contract ABI from the remix compilation details. This is your ABI, and then this is Web3 deploy. So after compiling this, we got the compilation detail, and from here we use contract data and contract ABI. In this one, we got obviously the Web3 and JSON. We converted the contract ABI to JSON dot loads. You have the Infura connection, the from account, the nones. We created the transaction object. The data was the contract data. We signed the object. We signed the transaction. So you got the transaction object signed, and then we send the transaction. This is the transaction hash. And finally, we got the receipt. After we get the receipt, that will be a contract address. Let's run it. So you see this is the transaction. And if you see here, this is waiting on the receipt. That means the transaction is still running. So let's see this. You see it says pending. So as soon as this is getting over, it is going to populate the contract address here. So let's wait. So I think it should be done in like less than 30 seconds or so. It could take longer sometime. So we're going to wait. You see that this is the data, and this is the gas limit. It's still pending because it is running, and it took around 16-18 seconds to run. Look at the gas price. It utilized 662.23 way, and we had this limit, so it was good. And if you go here, this is the contract address. The contract is ending in CA89. Go back to Web3, you can see that contract address is ending in C889. You see how we can read the contract address. Now, one more pro tip is, how do I read the status? So if I say transaction receipt dot status, you are going to read the status. Status of 1 means success, status of 0 means failure. So I'll say status is, and you can see it is 1. If in case of failed transactions, the status is going to be 0. So once the contract is deployed on Goerli etherscan.io, you click on the contract and you would see that this was deployed. And who deployed the contract? It was deployed by 3816. And if you go back, the from is 3816. That is how a contract from Solidity is deployed using Web3PY. I hope this was helpful. Thank you for watching.